Joining us now is Pete Lumbis, Lead Technical Engineer and Evangelist at Cumulus Networks, to offer some insight and technical detail and why it has been so important to IT to develop networking software that is automated and efficient for massive scalability that's built on open networking. Welcome, Pete.
Thanks, Ruby. So I'm Pete Lumbis. I run our technical marketing engineering organization here at Cumulus, and I want to talk about networking and building networks for the modern SDDC. So starting, Cumulus is built for cloud. We are the first native Linux network operating system in the marketplace. And what that means is we're not Linux-like. We're not the Linux kernel wrapped in some other stuff with a little pinhole. Everything we do is built and based on Linux. And what that means is we have actually contributed a great deal of information, collateral, and technology upstream to Linux. Whether that's our leadership in free-range routing, or FRR, the open source routing suite, and our contributions and leadership in EVPN there, whether it's the fact that we actually invented the VRF for Linux, so you can run VRFs on your servers for the first time because of the work that we've done. Or it's how we've rewritten the interface manager for Debian, and how that's been contributed and accepted upstream as a standard. Because we're native Linux, we have support for automation and telemetry out of the box without the need for workarounds or in-betweens. We provide fully disaggregated software that runs on a number of different platforms from a number of different vendors. So you can go and buy hardware from whether it's HPE, Lenovo, Mellanox, Dell, a bunch of different companies, and run Cumulus Linux on them and have the same operational behavior across your whole data center, campus, or out-of-band management. And we understand the need to simulate, train, and automate. And so we provide the ability for advanced network simulation. And we'll talk a little bit more about that in just a moment. And although we are built for cloud and we have this very forward-thinking way of doing things, we recognize that enterprises aren't always there on the bleeding edge just yet. And so we are enterprise ready. And so whether that means 24/7, 365 support, whether that means providing both automation and a CLI, or traditional protocols like spanning tree and MLAG, the ability to do things like SNMP or LDAP or TACACS, automation that can grow with you. So as your organization is working down this journey of network automation and programmable networks, we have software that will allow you to automate any level or any amount of that network that you're ready for and ready to consume. We provide 24/7, 365 support out of both Raleigh, North Carolina and Sydney, Australia. So again, providing you that support model that you've come to know and expect out of the existing network vendors. And as a quick customer testimonial, I want to mention Athena Healthcare, who's been a customer of ours for a few years now. And Athena is near and dear to my heart because they were actually a customer of mine when I used to be a systems engineer at Cumulus. And so I actually helped work with Athena and their team in their journey from traditional networking to this modern open networking ecosystem. And it's been amazing to watch this team of very traditional network engineers learn automation, learn how to simulate their network, how to test all their changes. And watching that journey and watching that team and what they've been able to build has been really incredible. Even things from an operational perspective where the primary reason they buy their switching vendor of choice is because that vendor provides ready rails that just snap onto the side of the switch and can be slotted into the rack in just a few minutes. And it's brought down their build time for any new data center builds from hours to minutes. And that one little component has huge implications on their business, but now, because of open networking, they can buy for the business instead of some operational restriction. So what is open networking, and what is it that we're trying to do here? And what it is it's taking the different components of that stack, where today you get hardware and software, whether it's from Arista or Juniper or Cisco, and it's welded together, tightly coupled. And there's no way to separate out those components. I can't take a Cisco switch and run Arista EOS on it. I can't take Juniper's BGP and put it on my Arista device. So what we want to do is we want to separate out those components to give you best in class at each layer of that stack. So best-in-class hardware, best-in-class network operating system, and best-in-class applications on top. And that's exactly what we're doing with Cumulus Linux and our streaming telemetry platform NetQ that we'll talk more about here in a few minutes. So getting into the nuts and bolts, what is Cumulus? What is it actually providing for me? We start with the industry standard hardware down at the bottom for your network switch. The CPU, the memory, the disk, the fans, and most importantly, that switch silicon. That ASIC is what's going to provide you that 48 ports of 25 gig or 64 ports of 100 gig or anything in between. And we are the software running directly on top of that hardware. So we are talking directly to that hardware, spinning the fans, flashing the lights, managing the disk, and programming that ASIC. And we do this through an entirely Linux ecosystem. So we use the Linux kernel as the source of truth. Any route, any access list, any MAC address, anything that ends up in the Linux kernel, we take and we translate down to that network ASIC. So you get that line rate performance with Linux operations. And because the Linux kernel is our source of truth for everything, on top of Linux are any of the applications you need to run your data center. So whether that's a CLI, layer 2 for spanning tree and MLAG, OSPF or BGP at layer 3, maybe you're doing traditional SNMP or streaming telemetry or automation or anything in between. All of these things simply talk to Linux, and then we make everything work. We make the switch look like a 48-port Linux server while operating at that 48 ports of 25 gig line rate. And I keep talking about the fact that we are Linux, and it's Linux at its core, and we rely on that Linux kernel as a source of truth. And that has huge implications, not just in your day-to-day operations, but also on what it enables from a testing and validation perspective. So if we have the software as our source of truth for everything, and we're never skipping past the software to program the hardware, we're using the software to make those decisions. Once I remove the hardware from that equation, what I'm left with is the exact same thing that can be put into a virtual machine. And we call that Cumulus VX, or virtual experience. So this is our free VM that is exactly the same software that's going to run on your switch. But now I can take that and I can combine it with a hypervisor like ESX or KVM, and I can simulate one-to-one exactly what that data center infrastructure is going to be. And whether that means one-to-one features for layer 2, ACLs, 802.1x, multicast, VXLAN, everything that works in Cumulus Linux software will work on our virtual machine. Each one of these can support up to 128 ports. So I no longer have a port limitation. I can easily build a virtual machine that looks exactly like the switch that I'm pushing into production. And I can rename those interfaces as necessary. And I have a very low memory footprint. One of the challenges we've seen in our customers when trying to virtualize their networks on their existing technology is that each of those VMs might take multiple gigs of memory to run, highly restricting what can actually be spun up in the ecosystem. And so for us, taking about 700 megs of a switch, it's very easy to scale out that entire data center, one-to-one replica. We boot extremely fast, 1 to 2 minutes, again, because it's native Linux. There's no translation layers there. I can rename interfaces to match production. So if I have 4 ports, I don't have to name them 1, 2, 3, and 4. I can name them how I've cabled up my data center, 1, 2, 14, and 18. I can build that one-to-one replica. I can make copies of it. I can clone it, and I can show it to my new engineers to get them training. I can tie it to an automation CI/CD pipeline for automated testing and validation. I can do what-if scenarios to see how our maintenance window is going to go over the weekend. There's a number of things that this really enables that nobody else in the industry can do. And we get this for free just by being a Linux-based system. So what we're providing here is a choice of hardware as well. So you can buy disaggregated hardware. So you can go to Mellanox or Dell or HPE or any number of hardware vendors to acquire your switching platform. Or you can come to us and we'll provide you a switch with what we call Cumulus Express. So it's really easy to try. It's that traditional way of buying. We see a lot of customers start with Cumulus Express and then move to a disaggregated model. But it gives you just another option to acquire the same type of hardware from just another source. And however you acquire it, it all runs Cumulus Linux, that same operating model, that same feature set, as well as Cumulus NetQ, our streaming telemetry platform. And so with Cumulus Linux, what we've done is we've created one OS that works across multiple use cases. So whether that's campus, data center, or edge, or DCI, it's all the same to us. It's different use cases. It might be different hardware platforms, but we're providing you one operating system, one unified model, end to end. All of that based on Cumulus Linux with open networking hardware. So unified configuration and operations, whether you're in out-of-band management, on the DC edge, or anywhere in between. That 24/7, 365 enterprise support, and end-to-end automation and orchestration. Earlier, you heard from our colleagues over at Mellanox, and I'll just take a moment to highlight some of their offerings. We have a very close partnership with Mellanox, and we've been working with them for a number of years to run on their Spectrum and upcoming Spectrum 2-based switching platforms. So they have a whole plethora of switches available, everything from 10 and 25 gig up to 1, 2, and 400 gig here coming out soon. Mellanox really focuses on end-to-end hardware design. It's very unique in what they do. So they focus on everything from the cable, the optic, the pluggable, up through the board, the ASIC, the CPU, every component in that system. Mellanox takes a lot of time and energy to make sure that they understand and engineer it exactly how they want it. They have one of the most advanced streaming telemetry platforms in their ASIC with what just happened. And it's their ability to capture a packet or a set of packets for any reason it was dropped on the switch, whether that was due to a buffer, an ACL, a route, whatever reason a packet might have been dropped on that switch, Mellanox's what just happened will be able to capture that information in the ASIC and stream that off. And when combined with NetQ, our fabric streaming telemetry platform, we can give you a fabric-wide picture of what that looks like and what is the health of your environment. And you have the ability to get support from either Mellanox or Cumulus, and you can have that single call for software and hardware, as well as 4-hour RMA options if that's something that you need. And I'll mention quickly their half-width switch for their Ethernet storage fabrics. This is the SN1010, and there are some new half-width switching platforms that'll come out here in the future. But it's 16 ports of 10 or 25 gig, plus 100 gig uplinks. And you can put 2 of these side by side in a single rack unit. So for those compute-dense environments where you might not have the space or the power to take multiple devices, these are perfect. It's very low latency. Mellanox actually provides the lowest latency Ethernet platform on the market at 25 gig and above. Supports for Rocky, RDMA, anything like that when you're looking at that really advanced data processing. Really purpose-built for HCI. So talking about smart buffering and fully shared buffers and equality in that system so that no one flow can starve out another. And what I think is really important is that it's actually 50% of the power draw of the equivalent switches from the incumbents out there. So again, when we're looking at power-constrained racks, this becomes extremely attractive. We recently announced our entrance into campus networking. So we've been talking about data center, and this is a data center-focused conference, but we also have campus networks and 1 gig and power over Ethernet to worry about. And so we provide you that ability with no feature limitations, no feature restrictions, no feature licensing. So I can give to you layer 2, layer 3, VXLAN, telemetry, all of it for the exact same price. There's no additional tax to build the right network for your environment. We have all of the standard campus features, so whether that's 802.1x, whether that's TACX, Radius, or LDAP, power over Ethernet, UPoE. NetQ that I've talked about that works in our data center environments also works across our campus environments. So I can monitor the same campus network as I would my edge or my data center. And simple management. Because of our native ability to do automation in streaming telemetry, I have an extremely easy way to manage my whole fleet of campus devices. Whether I need to make a single change to update passwords or adjust for daylight savings time, or if I need to do something like adjust how I'm going to change all of the switches in a single building or a single site. Extremely easy to do when you have native automation as part of the system. And so let's talk about the evolution of the data center and the SDDC and how we kind of see that world evolving. And so today, we have this legacy where we have these two big chassis switches up the top, and maybe we have some distribution and access layer switches below. And this is that legacy model, the access distribution core model. Usually this is all done with layer 2 and spanning tree. It is a scale-up architecture. So if I need more ports, I just buy bigger chassis. And I have to forklift upgrade each one of those chassis. And every time I want to do a software upgrade on it, I have to get the chiefs of staff to sign off on it. I have to swear my blood oath that everything will go fine, which it never will. And it's all extremely fragile because I have this giant monolithic system. And so what we're seeing in the modern data center is a move to spine and leaf scale-out architectures, sometimes called a cloth or a clo fabric. And so I add the leafs at the bottom for my server attach as I need them, and I can add spines as I want to add bandwidth to my environment. It's a scale-out architecture. It's all built on layer 3, so it's highly stable, highly reliable, highly scalable, and easy to manage. And if I have layer 2 extension requirements, I can use overlay technology at line rate in the switch with something like VXLAN. It's scale out, not scale up. So I can add ports as I need them, when I need them. I don't have to plan 18 or 24 months in advance when I make my capital investment. I can decide what do I need today and know that I can easily grow this out over time. This is a highly resilient architecture. This is the same type of architectures that all of the largest web scale companies in the world are building, whether that's Facebook or Google or Amazon or Microsoft. This is the way that modern networks are being built, is the spine and leaf scale-out architecture. But what's keeping us on legacy architectures? Most network engineers understand the problems that exist today and where all that heartburn comes from. And there's a whole bunch of different things that are keeping us there. We know that spine and leaf is the answer, but we have limitations and vendor interoperability problems. It's hard for me to deploy new things if they're not supported on my existing hardware. I can't take my Cisco switch and plug it into my Cumulus switch. I have trouble configuring these things. We've created a lot of complexity in the ecosystem and in the environment that it's just not worth it sometimes from an operational perspective to make that change. It's impossible to automate, whether it's because I don't have simulation, I don't have the ability to build my playbooks outside of production, or I just don't have the APIs and the ability to communicate to my network devices to automate them. Or it's just hard to learn and train. Again, this usually comes back to simulation. I don't have the equipment to train my people to get them up to speed on the new skills and the new technologies. Well, Cumulus Networks is the solution to all of this. And it's the combination of the right architecture, the right software, and the right operations. And when I take these three components and combine them together, I can solve all of the issues that are keeping us on that legacy architecture and move to that next generation data center. And so we start with EVPN and the topology that I just mentioned. And so the basis is dual attached MLAG bonds from servers doing LACP or not, but the ability to dual attach servers to 2 or more top-of-rack switches. This is not new. We're all doing this today. But what I add on top of that is adding that spine layer. And so what I do is I take some number of switches that I'm going to define as spines, and every leaf will connect to all of the spines. And so here in this illustration, I have 4 spines. So my leaf has 4 uplinks to get between any 2 leaves or any 2 servers in my environment. And I spread that out across the network, and that's my spine and leaf network. Now to configure the connections between the spine and leaves and make sure that I can have more than 2 and have that scale out bandwidth while also keeping it operationally simple, we at Cumulus invented something called BGP Unnumbered. And so it's the ability to follow the advice and the RFCs that have come out of Microsoft and Facebook on BGP in the data center, but doing it as simple as possible. And so BGP Unnumbered, it's based on an RFC if you want to get more information on it. But I'm going to build unnumbered interfaces, so I no longer need a /30 or /31 on each one of those links. And so as I look at a layer 3 network where I'm adding more and more links, I have to add more and more IP addresses and more /30 and /31 subnets, which is terrifying. So we get rid of that entirely. It's based on IPv6 and RFC 5549. So again, this is not a proprietary thing. We just make it really, really simple. And so what does that configuration look like? Well, I first off just define a BGP autonomous system number, and the instructions on how to do this are in both the RFC. You can talk to us, and we have a book on it as well. I define my set of interfaces, and I say, look, on these 4 interfaces that are uplinks, that's an external BGP peer. And then I enable EVPN for each of those 4 peers, and that's it. I've now configured BGP Unnumbered for my device and its 4 spines for EVPN. Extremely simple. And if you want to know more, we do have 2 free ebooks that you can go and download now. One on BGP, which covers BGP Unnumbered and building the design and architecture of this BGP-based data center, as well as EVPN, the motivators for EVPN, the different configuration styles, and why EVPN is really the solution to all of the problems in the data center. And so you can go download both of those books now from cumulusnetworks.com. So once we have BGP Unnumbered, we have that layer 3 core, we still have to address the need for a layer 2 overlay. There's always a legacy application or something that's going to do failover via layer 2, but I want the flexibility of that software-defined mentality where I can put any server on any port. And this is exactly what VXLAN and EVPN provides to me. And so I have this ability to have a standards-based overlay with VXLAN and interop with any vendor out there. And we actually have customers running Arista, Cisco, and Juniper with EVPN with Cumulus, and we've proven interoperability across all 3. This gives me that layer 2 over layer 3, so I can build that modern fabric and architecture without having to compromise or get rid of any of my legacy applications. I can make this a migration pattern and strategy on how to move forward. I can have local default gateways, and we'll talk about that in a second, but I can optimize my traffic flows within this EVPN spine and link network, whereas in the traditional 3-tier model, I'm always going all the way up to the core for any traffic, even in the same rack. Now I can make sure that traffic stays only inside that rack. And if I have a need for multi-tenancy, I can use VRFs to provide that. I can provide that modern cloud with tenant isolation for either virtual or bare metal systems. So there's 2 models that we see of customers architecting this spine and leaf network with EVPN. And the first one is what we call an Anycast Gateway. And so the idea is that top-of-rack switch will be the default gateway for a subnet, but it'll be the exact same gateway on every single top-of-rack switch across the environment. So no matter where a server lives, what VLAN or security zone it's in, maybe I vMotion across the network, that's absolutely fine because my gateway is always my local top-of-rack switch at that same IP address. Every TOR is the same default gateway for highly optimal traffic flows. I can still do L2 mobility exceptionally easily. And I have a DC-wide security zone. So I can have a set of tenants within any number of VLANs or subnets, and they can move anywhere they want in the data center. I can put their servers on any port, on any connection, and migrate them around however I need. And then I can use VRFs to isolate each of those tenants and do things like security or IP address overlap. The alternative to this is what we call centralized gateway. And we usually see this when there's a highly regulated or highly segmented network, for example, in financial services. And so I have a large firewall at the edge of my network, and that firewall will act as the gateway for everything. And so that single gateway location of the firewall is centralized as opposed to distributed. And so I can enforce all of my security and all of my policies at that firewall level. This is more of your classic data center design with that large firewall sitting at the north end of the network. And I'm still providing you that ability, but we're doing it over that layer 3 core where I can still have L2 extension and L2 mobility with the scale out and stability of layer 3. And one of the things that I keep talking about is simplicity and the ability to simplify operations and configuration. And EVPN is actually a place where I think we've done a phenomenal job of simplifying. And so when it comes to configuring EVPN, there's a couple of components. So first, I have to configure my server bond. And so I add 3 lines to configure my server bond. I add one more line to configure MLAG, or as Cisco calls it, VPC. One more line to define a loopback IP address on that switch. 3 lines for VXLAN, and 3 lines for BGP. And that's it. I'm done. Right? 11 lines of configuration, and I've completely configured EVPN. And that sounds great, and what does that mean, especially if I've never configured EVPN before? But if we compare it to a standard EVPN configuration, using industry standard CLI, you're looking at roughly 92 lines to get the exact same configuration out of that system. And that is on every single switch across that environment. This really adds up. Nobody in the industry is building simpler, easier, more user-friendly EVPN than us. And so how do we do this? How are we able to cut that configuration down so much and make it so much simpler? And a lot of it just comes down to smart defaults. We have a modern OS where we only enable the features that you're using. We don't have this big monolith with all this code running that you don't necessarily need. Only what you're using at runtime is ever enabled. We build that simple fabric. We talked about BGP Unnumbered, but we also have something called Prescriptive Topology Manager, or PTM. So I can validate that all of the cabling that's in place is exactly what I expect it to be. And if it's not, I can take action. I can automatically open a trouble ticket. I can open a Zendesk case or a ServiceNow issue. However I want to react to that miscabling, I can. We have very simple MLAG with what we call MLAG Unnumbered. So I don't have to assign IP addresses or define backups or anything like that. It all happens automatically. We figure it out. We have these computer systems. Why don't we have them do some work and some of the thinking? We have extremely efficient VXLAN with default ARP and ND suppression, so we're not spewing traffic across the network unnecessarily, and automatic route target and route distinguisher creation. And this is one of those things where, look, if you care about what an RT and an RD are, you can go ahead and create them and configure them. We will never stop you. But myself and many others, I don't care. So again, we'll figure it out for you. If you have an opinion, we never want to stop that opinion. But if it's a piece of configuration that, as I like to say, doesn't spark joy, then I don't want to make you have to have an opinion about it. And just smart, common sense defaults. A system MTU of 9216, so I don't have to go and configure jumbo MTU on every interface. A console rate of 115,000. So I'm not restricted to 9,600 bits or 9,600 baud when I'm trying to actually get into a console session to reimage a device or do an emergency recovery. And so this is just a way of how we think about our systems and how we're doing things to show that we really are putting the users first and really making sure that we're doing the enhancements and the feature capabilities, not just for new features and new technologies, but also thinking about that day-to-day operations. And so part of the core of this is our CLI called NCLU. And so it's a full CLI, supports tab completion and question mark, but everything starts with net. So if you can remember the word net, you can use our CLI. And we have built-in documentation and examples as well, but net add, net delete, net show, full system configuration and monitoring. As I mentioned, full built-in documentation and examples, so we can actually show you ASCII diagrams with the configurations on switch 1 and switch 2 for, say, a VPC configuration, or how to configure that BGP Unnumbered if you can't remember. It's built into the system. We offer commit and rollback, so as you make a change, if something goes wrong, you can easily roll that change back to the last good state. and a full HTTP API. So if you're looking at an API-driven configuration or automation capability or software-defined environment, we have that full API capability for you. The next thing we're thinking about when it comes to simplifying operations is BGP in the data center. So here I have the output of show IP BGP. And what we've done is two simple things that make huge differences in that operations. And the first one is supporting an IETF draft on host names. So we actually exchange and show the host name of a BGP peer instead of just an IP address. Because I am the human operator, I'm thinking in host names and device names, less so in IP addresses. So let's just show you that. And in this case, you can see that I'm showing the host name of the spine that's directly attached. But also BGP best path reason. I used to actually support BGP at Cisco, and the number of times I would look at this large BGP output and then sit and try to do the work, the long division of trying to figure out why BGP picked a path. Well, BGP knows, so we have BGP tell you the reason. And so here, you can see exactly why that path was picked and why it was best. So there's never a question when it comes down to operations. And so you can compare the legacy method without the host names, without the best path reason, against what we're providing you today. The next thing is talking about unifying operations. And that means between compute and network. And so we're adding Linux packages because we are Linux. All of these packages work out of the box. You could install them yourself, but we're going to start shipping with them here in the near future. And the first one is our MTR, Matt's traceroute or my traceroute, which is the ability to send a traceroute to an endpoint, find all of the hops between you and that endpoint, and then send constant pings showing you the loss, the delay, the latency along that path. Especially in these highly meshed, scale-out spine-and-link networks, this becomes extremely important to try to identify where there's failures in the system. HTOP, right? We know top, we know how to look at show proc CPU, and we're all very good at just running the same command over and over again and just comparing. Well, why don't we use a modern tool that's used on every Linux server on the planet, like HTOP, so we can get that highly detailed, very rich, user-friendly CPU, memory, and disk information in one dashboard. And then finally, BWM-NG, or Bandwidth Monitor Next Generation. So I can see rolling real-time stats of the interface traffic rates across every interface on that system. And then really where we're starting to shine here is in our streaming telemetry platform, NetQ. And I've hinted at this a couple of times, but I really want to dive into what NetQ is. And so what I do is I take NetQ agent that runs on box, and it supports anything Linux. So it runs on Debian Linux, Ubuntu, Red Hat, CentOS, and Cumulus Linux. Unfortunately, we don't run on the legacy networking vendors because they are not Linux operating systems. But if they were, we would absolutely support them. And this agent's running on each of those systems and exporting or streaming data up to a NetQ server. That telemetry server that's going to collect all that data, provide data analytics, and figure out what's going on. And so we record and stream data directly out of the Linux kernel. So it's all a push model. It's not a pull model. It's not the legacy SNMP method. It's the modern streaming telemetry method. Again, supported across the whole ecosystem of Linux distributions. And we're going to record events, dates, timestamps, changes in the system across both compute and network. And so if I'm a systems administrator, this is valuable to me because I can actually look at a MAC address on a server and see where a VM has moved and where it has lived over time. As a network administrator, I can ask a single question to find out what's wrong with my environment or what has changed over time. So we provide you end-to-end visibility with a graphical dashboard, a full feature-rich GUI built on a scale-out NoSQL platform. And you can deploy this either on-prem, but with either an appliance VM or a server appliance that we can provide to you. It's more heavyweight, but you get to keep control of that data. You keep it all in-house. It never leaves. Or if you don't want to maintain that, or maybe you don't have the resources, we do have a cloud-based offering where that server will live in the cloud, and you have a little tiny exporter and aggregator VM that will send data off into the cloud. And you can consume NetQ and its abilities and capabilities and analytics as a software model. So NetQ is a Fabric API, so I can ask information about routes or MACs or events, whether that's through the GUI, the CLI for my users, or through the API if I want to automate against it. And so we have customers doing things like building full CI pipelines using Cumulus NetQ, where they're validating and testing any network change before it gets deployed. Or when events are detected, they're having those events shipped off to Slack or PagerDuty. And so what we can do is we can see things like one-line validations. So it can say NetQ check BGP, and it'll look on every link, on every device, on every BGP peer, and tell me if something is wrong, and if there is an issue, exactly what that issue is. But we timestamp this and record all of the dates and times of the events that happen. So I can easily look back in time and say, okay, BGP is broken now, but what about 5 minutes ago, or yesterday, or Thursday at 4 p.m.? And in this example, I can see that it's broken now, but just in the recent past, everything was good. I have the ability to do trace routes that are layer 2, layer 3, and overlay with things like VXLAN from anywhere in that environment. So I'll analyze all of the data of my environment, and I can say if server 3 is going to send a packet to server 1, what path will it take, and what are all the hops in the middle? And again, I can do this historically as well as real time. I've been in so many operational issues where I'm sending a trace route and I get the report back and everything's great, but I know there was a blip or a brownout or something changed in the network, but I don't know what it was and I can't put my thumb on it. So I can run it historically and say, okay, well, what did that trace route look like during the reported time of outage? And so I can see if I look back in time, oh, there was an issue on this link or between these devices, or that was the thing that changed. And I can even look at the events. So I can have NetQ say, what were all of the events that happened? Or what were all of the linked events that happened? Or what happened yesterday between 2 and 3 o'clock? And NetQ can tell me all of this information. We recently added the ability to do full topology visualization, so I can actually visualize that topology. And I know, unfortunately, for a lot of customers, this will be the first time they've ever had a topology diagram that's up to date and accurate. But NetQ can collect the data from both compute and network and build that topology and connectivity map for you, as well as show you any issues on any links or any devices in that environment. We've also added the ability to do snapshot compares. So for example, if you're doing a software upgrade, here in this example, I've performed a software upgrade. I took a snapshot of my entire state of my network before, and I'm going to capture all of the routes and MACs and LDP peers and ARP entries and you name it. And I'm going to keep a record of that. I can perform my network maintenance, my software upgrade, whatever that change is, and I can take another snapshot and see what that state is, and then compare these two. And in this example here, as I look at and compare those two snapshots, I can see that a number of records have changed. So I click compare, I see that routes and MACs and all of that's good, but I have neighbors have changed, and I've lost some neighbors. And I can drill in and see that list that's changed, on what device it changed on, and when it changed. This has been one of the biggest pains for me as an operator historically is, well, what about the routing table? What about the number of MAC addresses? What did we lose in this software upgrade? And it's simple when I have a lab with 6 devices, but when I have 7,000 routes or 140,000 MAC addresses in my environment, I can't, as a human, go line by line and validate each one of those. NetQ does that for me. And so, just to wrap things up, we do have a number of ways to get started, whether that's reaching out to us directly, whether that's working through our training and education systems. We also have the only open networking Linux certification on the market with the CCONP, or Open Networking Professional. You can also go onto our website and try it for free. You can download VX or use it in the cloud. And that's all I have today. Thank you very much.